TLC, or thin layer chromatography, is a common analytical technique used in organic chemistry labs. TLC can be useful when you are trying to identify the components of a mixture or when assessing the purity of a sample. It is also used to monitor both reactions and purification. It takes time to become an expert at TLC, but this video should help you to familiarize yourself with the technique. TLC plates consist of a thin layer of a polar absorbent, either silica or alumina, on a solid backing, either plastic or glass. A fluorescent powder is also mixed in with the absorbent to aid with visualization. Samples are applied to the TLC plate using thin glass spotters. These spotters are made by heating and pulling capillary tubes. Once a TLC plate has been spotted, it is developed in a lidded chamber with a filter paper and 5 to 10 mL of a developing solvent. Before beginning your TLC plate, gather your supplies. You will need a pencil, a ruler, and a pair of tweezers. Assembling the chamber is fairly straightforward. Insert a filter paper into the chamber and then add an appropriate solvent. Cover the chamber and tilt to moisten the filter paper. This ensures that the air in the chamber is saturated with solvent vapor. This prevents evaporation of the solvent from the TLC plate while it is in the chamber. Remember to always use a pencil and to mark the dull side of the TLC plate. It is important to always wear gloves and to touch only the edges of the TLC plate. Contaminants from your fingers or other surfaces can absorb to the plate and affect your results. Draw a straight line across the plate 1 centimeter from the bottom. Mark this line with small ticks to indicate where the samples will be placed on the plate. It is important to properly place the tick marks on the line. If the tick marks are too close to the edge of the plate, the results will not be consistent. If the tick marks are too close together, you will end up with overlapping spots after you develop the plate. Make sure the edges and the ends of the plates aren't chipped or cracked. Spotting the plate is perhaps the trickiest part of TLC. Use a fairly dilute sample to spot the plate. If the sample is too dilute, you won't be able to visualize the spots, and if it is too concentrated, you will get large, streaky spots. Dip the glass spotter into the sample, then lightly and quickly touch it to one of the tick marks on the plate. This process may be done up to 3 times to obtain an adequate spot on the plate. Use clean spotters to apply the remaining samples to the plate. Using tweezers, place the plate into the developing chamber. Make sure that the solvent level is below the spots on the plate. Replace the cap to prevent evaporation of the solvent. Do not allow the edges of the TLC plate to touch the filter paper, as this will disturb the capillary motion of the solvent on the plate. Allow the plate to develop, keeping a close eye on the progress of the solvent up the plate. Once the solvent is 5 to 10 millimeters from the top of the plate, remove the plate from the chamber and mark the solvent front with a pencil. If the spots on the TLC plate are colored, you can move on to the next step. However, most organic compounds are colorless. Therefore, the plates will need to be visualized under UV light. The compounds on the plate will appear as dark spots when the plate is placed under UV light, enabling you to mark the spots with a pencil. To calculate the RF value, you must first measure the distance the spot traveled from the starting line. Next, measure the distance from the starting line to the solvent front. The RF value is spot distance divided by solvent front distance. This value will always be between 0 and 1. This value is dependent on the polarity of the compound and the polarity of the developing solvent. Polar compounds will have a lower RF value, than nonpolar compounds under the same developing conditions. As the polarity of the solvent increases, the distance of the spot travels increases. More polar solvents equal a higher RF value. The optimum RF value should be between 0.2 and 0.8. You may need to adjust the solvent accordingly in order to obtain the best RF values.